Before starting, I'll introduce myself. My name is Amira Lakhal. I'm an agile Java developer at Valtech. I also code in Scala in my free time. Despite coding, I'm also a running addict, and I'm happy to say that I finished my first marathon race last April in Paris. So that's me over there. If you'd like to hear some tech news, you can follow me on Twitter, and all the code of this presentation will be available on my GitHub account. I'm also one of Duchesse France leaders. Duchesse France is an association aiming to give more visibility to women with technical profile and help create vocations, new vocations. We celebrated our 6th birthday anniversary last week, so we're always looking for support from the IOT communities. Have a look on our website and follow us on Twitter. The Internet of Things. When I started doing some researches about the IoT, I was wondering when all this discussion about the IoT has started, and I found an interesting report from Cisco. The report shows the growth of population and, in the meantime, the increasing number of connected devices. And according to this report, as you see here, the IoT was born between 2008 and 2009 when the number of connected devices exceeded the number of population on Earth. So today we are about 7.2 billion people on Earth, and each one of you had at least 3 connected devices. And an estimation says that we are going to reach 50 billion of connected devices in 2020. So imagine this huge amount of network of connected devices with multiple technology, with multiple connectivity like wireless or internet. All these systems are contributing to the Internet of Things. And this system is actually capturing a huge amount of data. So we are, as we know, in the big data era. So today, if we only focus on social media users counts in 2 billion, and each one of them can have a lot of connectivity to content. Actually, there is 10,000 of connection to content. So we are facing a huge amount of data. Around a lot of zettabytes of data are here now. And the challenge is to speed analyzing all this amount of data. So actually, for example, if you look to the social media, Facebook has to load 20 terabytes of photo each month. And for example, Google is processing here in each 72 minutes, 1 petabyte of data. So the challenge here will be to analyze this unstructured data, most of the time text-based data, and to have the information from this data. To do that, we have to follow some steps. First, we have to extract the information from this data, and with the extracted information, we have to gain the knowledge, and with the gained knowledge, we have to enlarge our wisdom. So the future, what we're going to have, a lot of objects and things from physical and organic world are going to merge to the digital world, allowing a nearby real-time connectivity and analysis. So when machine and products will have the intelligence to deliver us the right information anytime to any device. And when machine and products have this capability, they can help us and other devices, of course, to have the best decision, improve our services, and of course, gain time. But the reality that we are very, very far away from this goal. Actually, I have in many occasions the possibility to see the robot here, and this robot is full of sensors. But this robot is only used for doing welcome speech in some companies and some events. Imagine instead of doing such simple things, this robot uses all these sensors and capabilities and all the data that he can capture to, for example, order your favorite drink when you're thirsty, maybe order your food, your ticket for your flight, and etc. So we are not using all the capability of the connected devices we have today. So that's why I'm only going to share my IoT world. As I told you, I'm a running addict. So to practice my activity, I use connected devices. The first one I started with is Runkeeper. It's a phone application that measures a lot of metrics while running: the distance, the speed, the calorie I consumed, etc. It was a little bit hard to do running with a phone, of course, because I have to hold each time the armband, and it wasn't really easy. So I tried the Garmin watch, my favorite devices, and with the Garmin watch, despite all the metrics I used to have with Runkeeper, I always have the real-time speed, and the heart rate measurement, etc. And I can synchronize all the data with my phone, of course. And the last one is the Withings, which is a small device that can measure all your daily footsteps to see if you have a healthy day or not. You know, we are all developers and we stay all the time in front of our computer, so this kind of device helped me to see if I did a very good activity this day or not, so I can practice at night. So today's goal will be to try to recognize physical activity with measurement coming from one sensor, which is the accelerometer. We'll try to recognize if we are jogging, walking, standing, or sitting. And this kind of measurement, for example, can be used for healthcare. Doctors can use this measurement, for example, to monitor the health status for some patients suffering from obesity and so on. And yesterday, of course, if you attended the closure keynote, there were some presentation of usage of accelerometer too. The accelerometer, as I said, measures the acceleration. So we can use it in multiple devices. Actually, it exists in all your smartphone. You have all accelerometers in your smartphone. And for example, if you like to go somewhere with Google Maps, it shows you the time to the destination and it measures the time using the accelerometer. So each acceleration we get from the accelerometer contains 4 information: the time stamp and the forces according to 3 axes: the x-axis, the y-axis, and the z-axis. And the unit is meter per second per second. So we get a lot of acceleration during a time interval, and that's what we call a time series. So we have a lot of measurement, a successive measurement during a time interval. Here, the first step will be to get this information from our sensor. And to get the information, I have implemented a very basic Android application just to listen to this sensor. So the first screen you're seeing here, you have the welcoming screen when I can put my server URL, and then when you click to start, you switch to another screen. At the beginning, you won't see any values. We are not listening to the sensor. When you click to the start button, you can listen to our sensor. All the code is available, of course, on my GitHub account, and it's open sourced, so you can use it. So after listening to our sensor and getting the data, we have to post it through a server. And here I used the REST server, a very basic one, to get all the values and store it to my database. So the first step is to store the data. And to store the data, I chose Cassandra. Does anyone know Cassandra? Used Cassandra? A few ones. So I'll do a little reminder. Cassandra is an open source project created by Facebook in the beginning. It's open source, of course, since 2008. It has the Apache license. And Cassandra is a NoSQL database column-oriented, which tends towards distributed table abstraction type. It's very supported by DataStax, which is an American company. So you can find a lot of documentation around Cassandra. What we have to remember about Cassandra is that it is scalable, masterless, very easy to operate, and we can have a lot of data centers, so it helps us to have a continuous availability with all these multi-data centers. So here what we're going to focus to is how to store data in Cassandra. So basically, when we want to store something in Cassandra, here we try to insert user's information, the login, the name, and the age. And to store the data in Cassandra, we use the SQL here. It's a Cassandra query language. Very similar to SQL, it's done on purpose. So here I stored my user, DuchesseFR, and with some information, which is the name and the age. So we have created a row containing 2 columns with name and age. And each column will have an auto-generated timestamp. And when we try to update the data, what happens, we're going to create a new SS table on our disk with the new information. So here we have a new SS table containing the age table, the age in a new table and a new timestamp, for example, of course, for this new column. And if we like to, for example, to delete the information about the age, what happens? We're going to create a new SS table containing a marked tombstone, which is the mark showing that we're not going to have the value anymore. So if you'd like to read the age, what happens? We're going to get the 3 assay tables to our memory, read the 3 of them, and only have the column containing the recent timestamp. In our case, it will be the last one, which is the removed timestamp. The removed, age with the recent timestamp. So as you see, in Cassandra, when you write, update, or delete, each time you have to create a new assay table with the new information. So actually it's great, but sometimes you don't like to store all this data. So if your disk isn't huge enough, you have to reach your limitation of storage. But with Cassandra, we have an automatic mechanism called Compaction, which occurs automatically and reads all this SS table, create a new one, copy the latest value in this new SS table, and remove the oldest one. So that's perfect, that works. But actually, do you remember that we are going to store measurement coming from accelerometers? So if the compaction occurs, we're going to lose a lot of information collected from our accelerometers. That's why we're not going to use this classic way of storage in Cassandra, but we're going to do historical data. So we're going to use time series data model. And for that, the first step to do is to define the 2 properties that are not going to change.